Welcome to Machine Minds, where technology and humanity meet. I'm your host, Greg Terrusian, founder of Samson Rose, a recruiting and search business focused on the robotics and AI industries. The Machine Minds show is where we dive deep into the intricate world of robotics and artificial intelligence. As a staffing industry leader with a passion for the frontiers of technology, I'm pleased to be bringing you intimate conversations with the founders, investors, and trailblazers who are at the heart of the AI and robotics revolution. In each episode, we dig into their journeys, the applications of the products they're working on, and the breakthroughs that are shaping our future. Join us as we explore how these machine minds are transforming the way we live, work, and understand our world. Whether you're an entrepreneur, a tech enthusiast, or just curious about this amazing field, you'll learn something new with each episode. Let's delve into the extraordinary. Let's delve into machine minds. Hello and welcome to Machine Minds. I'm your host, Greg Terrusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Chester Leung, co-founder and head of platform architecture at Opaque Systems. Thanks for being on the show today, Chester.
Yeah, thanks for having me, Greg. Super excited.
Yeah, my pleasure. Let's jump into it. So look, Chester, can you share your journey into computer science and what sparked your interest in confidential computing?
Yeah, sure. So this is actually a pretty funny story because originally I did not know I wanted to do computer science. I ended up at Berkeley as an undergrad. Originally, I was super interested in economics. The way that it kind of governs, the way that we operate, all the structures and other stuff that puts in place. But being at Berkeley, a lot of the student population was very focused on computer science. Computer science back then was a super hot topic. As a result of kind of, maybe you would call it peer pressure, societal pressure, whatever, I decided to enroll into some computer science courses. At the time, I remember the introductory class was 2,000 students. So we had the course in, the largest auditorium on campus. And I still remember very vividly the first day, there were students sitting on the stairs, students blocking the exits and the entrances. It's an absolute fire hazard. But that was kind of my earliest introduction to computer science. And as I, continued taking more courses, what I realized is that a lot of the fundamentals and a lot of the concepts that computer science taught could be applied to my everyday life. And that was kind of the reason that I fell in love with computer science, was I found it so applicable to a lot of things that we do today. And a lot of the concepts there could, almost govern the way that, I live in a more efficient and optimal manner. So that was kind of how my introduction to, computer science began. And the introduction to confidential computing in particular, when I was, I think, a second year in my undergrad, I decided to join Raluca, who is now one of my co-founders, but Raluca Adipopa's research lab at Berkeley. Raluca is, one of the system security professors at Berkeley. And the reason that I was so interested in joining her lab in particular was that, again, kind of going back to my earliest days at Berkeley, Berkeley is, at the time at least, was very notorious for having a bunch of classes that students could not enroll into because the demand for those classes was so high. So in particular, the classes, had maybe 50 spots, maybe 100 spots, whatever. And there were, 500 students, maybe more, that really wanted to take that particular course. And as a result of that, the demand for the course was very high. And, the minute that enrollment opened, students would, be on their computers, clicking buttons as fast as they could, almost like, ticket scalpers do today, to try to get into class. So it was super competitive. And I, did the same thing. I was online at, for example, 12:59 p.m. When enrollment opened at 1, you refresh the page as quickly as you can. And then you try to click enroll into the class as early as possible, so that to optimize the chance that you have to take that class. And I was actually able to take a lot of the courses that I wanted, but somehow about a week before my first semester, the system, at least from what I thought, completely bugged out, and it dropped me from all the classes that I had. So I was kind of left with no course schedule. Because I of course tried to re-enroll in the classes, but I was at the bottom of the wait list. Yeah, bottom of the wait list, like 400 people down. And that was what made me realize, like controlling your data, having control over your data is a super important thing. And for me, I felt super frustrated, super disappointed, super overwhelmed because I wasn't able to get into class. But then I realized that there are people out there who have their credit card numbers stolen, their identity stolen, all of that thing. And for them, it wasn't a matter of not being able to enroll in that class that semester. It was a matter of everything that they've ever worked for was no longer there because these financial criminals, these cyber criminals were taking away all of their stuff. And that was only possible because of the kind of digital age that we live in today, where data really governs a lot of how we operate as a society. And it was kind of through that fundamental experience that made me super interested in exploring how we can develop research, how we can develop technologies in a way that allows people to retain control over their data. And what I thought back then was, if we can just develop something or make it a little bit more difficult for these criminals and for these systems to do things in a way that, force people to lose control over their data, then that would be, maybe a little bit better for the world that we live in today. So that was kind of my primary motivation for joining that particular security group. And I was very fortunate back then that, the security group, being at Berkeley and, kind of being at the forefront of research and being in the state of the art, they were focused on a number of different technologies, one being confidential computing. So confidential computing was an area that we explored. We were also very fortunate to have, Intel as kind of a very close partner to the group. Microsoft also is a very close partner to the group. So we were very fortunate to have kind of advanced access to a lot of the technologies that were still, really being developed at the time. And I think that, kind of allowed me to, gain entry into or have some more visibility into technologies that were not yet really in market.
Interesting. Interesting. Wow. So that first-hand experience, I had no idea that the courses were so in demand. And that's, I mean, 50 or 100, that's such limited spaces. That's crazy.
Yeah, yeah. So it was pretty brutal. The 50 to 100, I think, were more of the, like English classes, for example, some, history classes. The computer science classes had much more space, but
Got
the
it.
demand for those classes was also so much more.
Yeah, I bet.
So that was challenging.
Cool. So let's move on. So after your time at Berkeley, you obviously founded Opaque straight after that. Let's talk about that because we talked offline a little bit about the labs, and I don't know how many of our listeners are familiar with it because it was actually a learning experience for me when you were sharing about how the labs actually work and then the startups that come out of them. And you obviously mentioned your co-founder who led the lab that you joined. So how did this academic experience, this lab experience, influence your decision to start Opaque? And just talk us through like those steps.
Yeah, sure. So let me give a little bit more background on the lab model. Again, so at Berkeley, there's a family of labs that are essentially rebirthed every 5 years. And every time there's a birth of a new lab, the vision for that lab changes. So back when I was there, the name of the lab was called RISE, RISE, and it was an acronym for Real-Time Intelligent Secure Explainable Systems. So that lab was focused on that particular kind of sector, or not sector, but that particular kind of area of research around kind of building these systems that were real time, that were intelligent, that were secure, that were explainable. That iteration of the lab kind of shut down, and then the new iteration of the lab that is kind of the current iteration of the lab is called Skylab. And the vision behind Skylab is that there is almost a unified cloud. So in particular today, the cloud is fragmented. You have Microsoft Azure, you have Google Cloud, you have AWS. And the kind of vision behind Sky is, can we build a unified sky, quote unquote, above the clouds that provides some kind of unification layer over the clouds, for example, to optimize cost, to optimize data transfer, that kind of thing. So that is kind of the working model of the labs at Berkeley. And in my opinion, the very powerful thing about developing a novel North Star or a novel vision every 5 years is that it really enables you to stay at the forefront and stay at the frontier of research, of innovation, of technology. And also as part of the lab, we were very fortunate to have industry sponsors who helped to sponsor a lot of the research that we did. And their sponsorships also enabled the researchers, the faculty, the students of the lab to guide and shape the research in a way that allowed the research to tackle existing problems that these industry companies, a lot of them are Fortune 500s, that a lot of these industry companies were facing at that particular time. And another kind of pinnacle, not pinnacle, but another kind of key tenet of the lab is that a lot of the research should be developed in open source, because that enables a free flowing community, enables an open collaboration. It opens kind of ideas to be exchanged freely, not only within the lab but across the world. So we have this kind of combination of industry sponsors guiding and shaping the research. We have this combination of open source research as well. And as a result of that, because the lab was able to, the students of the lab and the faculty of the lab were able to build and develop projects that solved concrete problems in the industry, a lot of the open source that was developed to solve those problems gained a lot of traction. So for example, Apache Spark is one project that came out of the lab. And as many of us know, Apache Spark still forms the foundation for Databricks, which is a very successful commercial company. Similar with Ray. Ray is at its core, a distributed systems framework to make distributing workloads much easier. Ray became Anyscale, and then a lot of the research that today my co-founders and I built is called MC2, and MC2 is a platform that enables what we call secure collaborative analytics and machine learning. So solving the problem of you have multiple parties, each party has some sensitive data sets that they want to pull together. How do you enable these parties to work together to gain insights on these shared but sensitive data sets in a way that preserves the privacy of the data, while still being able to enable these parties to intelligently gather these insights? So that was kind of the core focus, the core mission of the open source project that we developed. And today, Opaque technology is based off of a lot of the work that we did with MC2.
Very cool. So let's talk us through the inception of Opaque. What challenges did you and your co-founders face? And who are the co-founders? Is it just you and you're one other co-founder, or are there other people in the founding team?
Yeah, so we have 5 co-founders. Raluca, who I mentioned, she was my advisor, is one of them. Another one of our founders is Jan Stoka. So Jan is also a faculty at Berkeley. He actually co-founded Databricks and Anyscale as well. We also have Rishabh. So Rishabh today is our CTO. Rishabh also did his PhD at Berkeley. And then lastly, we have Wenting. Wenting also did her PhD at Berkeley and now is a professor as well of computer science at Carnegie Mellon. So we had 5 co-founders. And what was the question that you asked?
I was just curious about challenges, because early stage companies and founding the companies, it's sometimes a what's the words that I'm looking for? It's like a shiny object for some people. Like, oh, I want to be a founder, I want to be a CTO, CEO, whatever. But I like to hear about some of like the hurdles people overcome, or like the rough road that it is to found a company. Finding people, finding ideas, like the first bit, but getting traction, getting funding, getting the ball rolling, hiring new people. There's always some things that are less desirable than others.
Yeah, absolutely. Absolutely. So I think, in terms of the people, right, we were very fortunate to have worked together for a long time before we actually founded the company. And as a result of that, we were confident that, we would be a great team together. And that still holds true today. In terms of, kind of getting funding, kind of getting traction, I think we were also in a fortuitous position at the time as well, because because the lab in the past had produced a number of very successful open source and then commercialized companies. There were already some kind of investor eyes on other open source projects that the lab was developing, and we happened to be one of those projects. There were some investors that actually approached us before we were more concrete about starting the company, and they kind of approached us and asked, what do you guys think about taking what you guys are building and commercializing in the company. And the investors that helped us back then have been super helpful throughout our entire life cycle. They helped us to of course develop the product, but also gave us guidance on what it actually means to launch a company. Because we were five academics, we loved building research. And I think our kind of primary collective motivation or shared motivation was that we really wanted to see what we were building impact what the large companies were doing at that time and into the future. We just thought it would be so cool if the stuff that we were building was actually used by a lot of people, and it was actually doing ideally a little bit of good for the world, right? Preserving the privacy, returning the fundamental rights to privacy to a lot of these consumers. And in terms of I'd say one of the kind of big challenges that we faced early on was that because the idea and a lot of the technology that we had built came from research, the technological concepts and even the term confidential computing was not very well known even 4 years ago. So we had to do a lot of market education as a result of that, just to help people understand what that technology is about, what the benefits are, how in particular how it can apply to their business use cases, and how it can deliver value for them. So we did a lot of market education. Today, I'm actually super happy to see that probably more than 50% of people actually know what confidential computing are. So when we go to talks, when we go to conferences, people will be like, oh yeah, I've heard of confidential computing. I generally know what it is. 4 years ago, that was absolutely not the case. Nobody had heard of it. Every time you say the term, they're like, "What did you say? What does that mean?" So I'm really happy to see that it's not just us, of course, right? There's a number of companies building this space. The cloud vendors, I think, all picked up early on this would be kind of the next big thing, and they've also developed a lot of tooling, a lot of infrastructure, even some services around this confidential computing technology. So there's just kind of been this kind of growing wave of companies, of individuals, of researchers doing work in this space. I think that has really helped propel confidential computing to the forefront of a lot of people's minds.
That's awesome. I'm glad that you mentioned that, because sometimes that's like a major sticking point, a major hurdle for companies to overcome when they're building something that is hugely impactful, is very interesting, has a big use case, but people don't know what it is or how it can benefit them. So that educating your market is sometimes creating a new market, really, in a lot of ways, right? Like people don't know what they need. Like, here, let
absolutely.
me spoon feed you the benefits of this. Yeah.
Yeah.
So,
Yeah.
so for people unfamiliar with confidential computing, unfamiliar with Opaque, can you explain what your platform does in a nutshell and the problems that you address?
Sure. So Opaque, first of all, is builds what we call the confidential AI platform. So the particular problem that we're solving here is that what we've seen is that especially during this age of this kind of generative AI gold rush, or whatever you want to call it, where everybody is so excited about kind of the benefits that generative AI in particular can bring to their everyday lives, that can deliver business value, whatever. We're seeing that in the enterprise, there is almost a struggle in taking these AI projects into production and actually extracting value out of these AI projects, not because of the AI technologies themselves, but because there's an issue, grappling with managing, ensuring the privacy of a lot of the data that powers these workloads. Data fragmentation is a huge issue. We've also seen kind of existing privacy preserving techniques like anonymization, not really doing a very good job. There's a very manual process. They don't really preserve privacy. So companies are really struggling with kind of getting a grasp on their data and finagling their data in a way that can accelerate or enable really their AI workloads to get into production. So that's the kind of the big issue that we're solving. And our confidential AI platform provides them with verifiable controls. It provides them with encryption and use technologies. So, for example, confidential computing that allows these companies to operate their data in a way that preserves the privacy of the data, but also in a way that does not affect the results, the insights, the kind of intelligent decision making that these AI workloads are actually able to offer. So the platform builds on top of confidential computing, on top of the kind of confidential computing stack. And I'll explain what confidential computing is in a bit. But at Opaque, our platform offers you business applications on top of confidential computing. And what we've found is that has delivered a lot of value because confidential computing itself is not the easiest to work with. There are a lot of things that you need to consider on the security side, on the system side, to make sure that things scale, on the performance side, to make sure that the confidential computing capabilities and guarantees are actually able to be, to actually deliver value to the end user. So that's kind of where Opaque is. We're business applications on top of confidential computing, targeted towards kind of the data scientists. So for example, the data scientists can run a PySpark notebook. They can run a SQL job on top of our platform, and kind of receive all of the benefits of confidential computing, and receive additional benefits like verifiable controls, verifiable audit logs, all of that, in a way that does not force them to understand what confidential computing is underneath.
Interesting.
So
who's
yeah,
ideal customer? Like, what type of businesses or type of customers do you approach or actually use your systems?
Yeah. So who we're targeting right now are the very large enterprises, data teams at large enterprises, engineering teams at large enterprises, who are responsible for building a lot of the systems that orchestrate and run these AI workloads. We've seen it's these teams that struggle with this data challenge, and it's these teams whose projects are making it to production, I don't know, 10% of the time. And as an engineer myself, that's super frustrating, right? Like you grind on this project for 6 months, 8 months, and then you realize at the end that you're having some data challenge. It's not even an AI challenge; it's a data challenge, and your project gets axed.
That sucks. Yeah,
Yeah,
that really sucks. So the market, you mentioned, AI and this gold rush bubble that we're in. It's obviously a competitive market. And then you mentioned there's multiple people in the confidential computing space as well. What sets you guys apart? What's unique about what you're doing?
yeah. So what we focus on is the business application on top of the confidential computing stack. So in particular, right, what we've seen in our experience initially in the research days and even now is that, as I mentioned, you need a lot of expertise to be able to productionize confidential computing, and not actually most enterprises don't have this expertise in-house. So their options are either they build a team, attract a team in-house that can kind of build all this stuff themselves, or they come to our platform and they don't need any of that expertise, right? They have their machine learning engineer today, they have their data engineers today. The data engineers, they can use their exact same notebooks, exact same code, exact same languages, frameworks, tools, whatever you want to call it, and they'll be able to harness the security guarantees and the performance and the scalability of our platform without needing to understand any of the stuff that happens underneath. From what we've observed, right, there's a lot of companies that are operating a little bit more down stack. So they provide almost developer tools that make it easier for these security systems guys to build these systems. But still, there's still one level above that where the data analysts may not be able to do a lot of that stuff, provided
Yeah,
only these tools from these lower stack confidential computing companies.
got it. You mentioned that confidential computing can be kind of difficult. It's not the easiest to work with. And some people argue that confidential computing adds complexity without substantial benefits in some cases. How do you respond to such critiques? Or is there a particular environment or use case that this is like a no-brainer and must be used?
Yeah, so a couple of thoughts there, right? I think the first thing is a lot of the use cases will not even be possible without a technology like confidential computing because of the privacy concern, because of the regulations, all of that. So that is strictly additional value that you're getting because the use cases will not be feasible without a technology like this. that preserves the privacy of the underlying data, that proves to the data owners how, and I'm not just talking about confidential computing here, but I'm talking also about kind of the additional features that Opaque provides. It's strictly additional value that you're getting as a result of using the platform. And from what we've seen as well, there are also other use cases where, things that were previously possible. So things that you were, getting some existing value from, let's call it X, are now no longer possible because of these kind of additional incoming regulations from Europe, from the US. So there you're seeing you have this baseline, and because of these, because of this kind of movement in the regulatory space, that value X is actually decreasing because you're no longer able to do these to run these use cases. But if you want to get that value back to X, you will kind of have to use a technology like confidential computing or technology like Opaque in order to kind of revive that value that you've previously already been getting.
So you mentioned this stuff coming from Europe and everything like that. How with these increases in data breaches and things like that, how does Opaque ensure robust privacy, data privacy, and compliance with these global regulations?
Yeah, so a couple of things that we do. There's what we found to be super important for our customers is this idea of verifiability. From what we've seen, right, with, for example, the whole kind of Apple private cloud compute thing. I'm not sure how familiar are you with that, so I'm happy to give you a quick background if
Yeah, please do.
that'll be helpful.
Please.
Okay.
Yeah.
So, and this is just my understanding of it, so I'm not sure if I'm 100% correct, but from what I've read and from what I've heard, with this Apple Intelligence feature that has come out on a lot of Apple devices, you have for example, your iPhone, and if the user wants to integrate Apple Intelligence into it, they have a couple of options. Number one, they ask Siri a question, for example. Siri can run the computation to answer that question on device, and that is obviously the most secure option because all the computation happens on device. None of the data leaves the device, and that's kind of it. The second option is for whatever reason, Apple Intelligence believes that the user's question cannot be answered properly on device. And then they send that user question to something like OpenAI. In that case, OpenAI has, they basically have access to whatever data the user or whatever question the user is asking, and then OpenAI, generates a response, and then it sends it back to the device. The third option that is a kind of a novel innovation, I would say, in kind of that space, is that Apple has developed something called private cloud compute, which is essentially their version of confidential computing run in Apple data centers. So Apple has developed this notion of private cloud compute. What that means is that you have your question on the device. The device relays the question to Apple's confidential computing servers, and Apple generates a response within these servers, and then the servers send the response back to the device. The key piece is that because the private cloud compute is running within confidential computing, Apple itself cannot see the underlying data that the user has actually sent to Apple's servers. And that is where Apple, in my opinion, has set itself apart from some of its competitors, is that it's saying we're able to run generative AI on your behalf, but even we as Apple cannot see what you are asking us. And that's a very, very, very powerful paradigm. Now, going back to my original point around kind of verifiability, in confidential computing, there's this kind of paradigm or tenet or whatever you want to call it, where you have these servers, these confidential computing servers. How do you make sure that what you expect is running in those servers is actually what is running in those servers?
If you don't have access, you mean, if you can't see what's going on?
Yeah, kind of, right? So like, how do I, for example, trust that you're actually doing what you say you're doing? Right. So like, maybe to give an analogy, maybe you tell me, Chester, like after this recording, we will divvy up the recording into 5-minute segments. and then we will send you those 5-minute segments, or send those 5-minute segments somewhere else. And in this case, I'll need to trust your word, which I do, by the way, but I'll need to trust your word. But in the cryptography space, there's this entire problem of how can I actually verify that you're doing what you say. So that's the kind of same kind of paradigm idea in confidential computing, and that paradigm is called remote attestation. So remote attestation enables you to verify that what is running on the machine is actually what you expect. And as part of that kind of chain of calculation or chain of measurement, I as the user need to verify that what is running is what I expect. So there's this notion of kind of verifiability that is very tied into this entire space. And kind of verifiability is what we've seen be a very key part of what we've been able to offer here at Opaque, right? Is like allowing the customer to verify what is being run on Opaque. And in particular, what we found to be super, super valuable is allowing the customer to verify how data is actually being used. So, there's a data owner, there's maybe a different party that's processing that data. That different party must be able to verify to the data owner exactly how their data is being used.
Would you say that that's one of like the biggest hurdles that organizations face when they're adopting confidential computing, or is there anything else that is a kind of roadblock?
I think that's definitely one of the kind of key aspects. Remote attestation that I mentioned earlier is also another roadblock. I think people don't, technically in the details don't quite understand what that actually means and how to implement it. So that requires a little bit of kind of low level system security expertise. And on top of that, there's confidential computing, and as I mentioned earlier, there's kind of the business application. So how do you run the business application in a way that is performant and scalable? Because as you know, right, compute costs a lot of money. And for a lot of companies, compute is maybe one of the largest costs that they face. So we need to be able to do it in a way that is performant and scalable.
How does Opaque assist with overcoming these hurdles? How do you help your customers like really embrace this and make sure it's smooth for them?
Yeah, sure. So I guess now I'll talk about a little bit about our process, our onboarding process, and how we kind of help the customer ensure that what they're doing is what they want, and will actually deliver value for them going forward. But we, in our process, we really try to understand exactly what our customer is looking to do. So sometimes they have a vague idea or this general idea that they're having some kind of data challenge, but maybe they're not exactly sure how to solve it. Maybe they're not exactly sure what they want either, or what they're trying to protect against. So it's important that I think together we're able to articulate what exactly it is that they're trying to solve for, and in particular what problem they have that they're trying to solve. And then after that, right, we create a what we call a strategy map of them to ensure that their business objectives aligns with, or their business objectives align with what we're able to provide here at Opaque. And then if necessary, we'll do a little bit of configuration of our platform to ensure that the platform is able to deliver value to them in a way that actually provides value, and that actually aligns with what they're trying to do.
Nice. Let's shift gears for a second and talk more about team building, company culture, things like that. Because obviously, as a co-founder, you're involved in all of these areas. What qualities do you prioritize when you're building the team, or when you're looking for people to join Opaque?
Yeah, I think one of the big things that we value as a team, and that I have always really valued, is this idea of ownership. So I'm sure at a small company, right, you can't really just wait for things to appear at your desk. There's a lot of things happening all at once, and being able to kind of see a problem, fix a problem, or see a solution, find that solution, share that solution, execute that solution. I think it's very, very important for us, right? We really try to empower all of our teammates to have that agency, and to feel that sense of agency, so that they're able to so that they feel kind of comfortable and willing to bring up any of the issues that they see. I think that's super important. And um, building an environment in which our team will thrive entirely. I think another thing that is super important for us is that this is not something that came naturally to me early on, but this idea of customer centricity, right? Obviously, our company came out of a lab. We didn't really have commercial customers. We didn't have much experience with that. But something that I've come to realize is that the customer is so important, and we need to understand exactly what the customer wants. We need to build everything in a way that makes the company that makes the customer super happy and delighted with what we're building. So having that kind of customer centric focus is also something that we find very valuable.
That's great. Yeah, I think it's super important, especially like you mentioned in a startup, having those things, because if you don't, and sometimes people fall short when they're trying to hire, right? You just think like, oh, all I know is, for example, your team are all academics, right? I know academia, or they've come from large companies, and we know large companies know they've got good people, but the way of work is very different when you get to a commercial startup, right? And then, like you said, that ownership or maybe pace of work or things like that, it's very different. The customer centric elements as well, especially if you're coming straight from research, right? Or academia, how do you change gears to be focused in that way and think about that outcome? Yeah, very true.
I've seen like research is obviously, or academia is one kind of area where there's less of a focus on that naturally. But I think even at big companies, right, where so many teams are so insulated from the end user or the end customer that a lot of their work almost gets lost in kind of this maze and this sea of different projects of who's actually my end user, who am I building for, what problem am I solving for the end user. I think that entire thing gets lost.
So true. Even sometimes you can be so, I guess fragmented is the right word, because you don't do the whole from initial concept design, prototype, like from that to publish to a release product. Sometimes there's so many different teams where you do this part and then you pass on to the next person to that part and then it goes on. So you don't ever really see the full life cycle. And then you don't have that sense of ownership or, like you said, the sense of like the customer at the end. So yeah, it's different things to think through when you're looking for people to hire. Have you thought about how you kind of foster that culture of innovation or that culture of ownership and customer centric behaviors?
Yeah, so I think we're very lucky in that that the initial kind of founding team and the first couple teammates that we brought on were all kind of from our lab, and as a result of that, at the beginning and continuing into very early on, we really embrace this the sense or this culture of innovation, of challenging one another. We made sure that to create an environment where people are willing to throw ideas out there, however kind of far fetched they may be, and try to detach their egos or their kind of sense of character from these ideas. And I think this kind of comes from the research background. We challenge the idea. You make sure that what you're building is correct. It doesn't matter who the idea came from. Um, all we care about is building the right things for the right reasons, and nothing else kind of beyond that matters. And I think that that sense has really permeated throughout kind of the years and throughout the growth of the company. And I think that's really helped us to foster the environment where it's really all about building. All we care about is building. It doesn't matter, where you come from. It doesn't matter what you did previously. All that matters is kind of the stuff that you bring to the table, in terms of ideas, in terms of um, why you're doing this.
Love that. And just for the listeners as well, when did the company start and what stage are you guys at? How many people are you? How much have you raised? All those kind of data points.
Yeah, sure. So we officially launched in January 2021. We were doing research for a number of years before that. As I mentioned earlier, the technology from the research today forms the foundation of Opaque. Um, yeah, so right now I guess it's November 2024, so that makes us almost 4 years old. Our birthday is actually January 1st. So, once a new year hits, that's another year for us. We raised a seed round early on, and then we raised a Series A following that. In total, we raised about 32 million.
Awesome. And how big's the team now?
The team's about 35, 40 people.
Awesome. Very cool. Diversity is obviously a hot topic and has been for quite some time in the tech industry. It sounds like your founding team is very diverse. How do you guys approach building an inclusive and diverse workforce? Is that a main focus for you, or do you have initiatives around that?
Yeah, so we really value diversity of thought, diversity of background. In my particular, diversity of perspective is so important in building a strong team. I think, as I mentioned earlier, our entire goal really is to be able to build the best stuff possible, and to ensure that our customers are happy with what we built. And that's kind of, all we care about. As I mentioned, diversity of perspective, right? Something that we really value. So perspective comes from backgrounds, it comes from experiences, it comes from kind of the way you grow up. So we really place a very strong emphasis kind of on diversity there.
Yeah, great answer. Let's talk about the future, because the tech industry, AI, computing it's moving so fast right now. Like every month, there's so many new breakthroughs and new things that are coming out. Is there anything in particular in AI and confidential computing that you're most excited about for over the next few years?
Yeah, and I'm happy to answer this question, but I'd love to hear your thoughts too, just to kind of see what you're thinking. But I think right now, right, it's really the early ages of what people are calling agentic AI, right? So we've had this kind of initial wave of generative AI, where a lot of it is really kind of advanced pattern recognition, right? So you ask ChatGPT a question, and then ChatGPT will kind of comb through all the data that's ever been trained on, and give you a response. In that particular paradigm, from what we've seen, the faster the ChatGPT responds, the happier the user is. That's kind of why ChatGPT 4.0 was so kind of groundbreaking, was that the response time was so low, and the responses were pretty decent. Now, we're entering an age where kind of the rise of what people are calling cognitive architectures are coming about. So these are models that they're not focused on responding as quickly as possible. Instead, these models are reasoning. It appears that they actually have a brain, and as a result of that, they're able to reason and to deduce and to make logical decisions. And as a result of kind of those reasoning capabilities, people are saying that kind of this next frontier of generative AI is kind of generative AI models that are able to reason and that are able to act as agents. So they're able to make decisions. They're able to call into different services, work with different data sets, automate away a lot of the stuff that is very repetitive for people today. For example, sending an email as a calendar invite. Today, what do I have to do? I have to compose an email, figure out what that person's email is. I got to write the subject. I have to look at my calendar, look at the other person's calendar, generate a Zoom link, put it all in my email, and send it. So the kind of promise here, right, is that these agents will automate all of that away for you. And the difficulty there is that these agents actually need to call into different systems. Right? They need to call into email, they need to call into calendar, maybe they need to call into my contact book, they need to call into Zoom. So yes, this promise of agents is super promising and super exciting. But my perspective here is that you cannot just unleash agents on the systems that we have today, right? Agents and AI in general is kind of non-deterministic, and as a result of that, it may act in ways that we may not expect. So, for example, Claude has this agent called Claude AI Assistant, something like that. It's built by Anthropic. Anthropic built Claude, and there was an observation made by a team of researchers where they tried to allow or have this Claude AI agent perform some coding task. And in the middle of the coding task, this agent randomly started looking at pictures of Yellowstone National Park. So actually very reflective, I think, of what a developer would do.
I was gonna say, it seems like just
Right.
like what an employee might be doing during the day. Yeah.
Yeah, exactly. Right. So maybe it's trained a little bit too well on real life data. But
That's good.
my point there is that it may go a little bit off of what it's supposed to be doing.
Yeah.
And that is a relatively benevolent case. But I can certainly imagine instances where instead of, for example, accessing data, it overwrites some data, or it shares data to, maybe another agent or to some employee that's not supposed to do. And yes, we can place guardrails on top of this, but that research is also very new. And even if we do place some kind of framework or guardrail framework on top of that, it may still act in ways that we don't expect and that we haven't thought about. And as a result of that, maybe operate on data in ways that are not permitted. So this is kind of where I see, opaque, confidential computing, kind of security, privacy tying into this whole agentic AI landscape, is that we need to build our systems that agentic AI operates on in a way that thinks about how these agentic AI agents or agentic AI could operate. So we need to put the proper controls in place. We need to put the verifiability in place. We need to put the privacy by default in place so that when these agents start operating on these systems, even if they do go and do things that they're not supposed to or that we don't expect, there is minimal damage, if at all. Right now, from my observations and from my experience, it seems that a lot of these systems are architected in a way that assumes that the user is benevolent. And most of the time we are, right? We're employee, we want the company to do the best it can. We don't want, we're not intentionally trying to leak data or breach data or anything like that. So I think right now that is a fair assumption to make. My fear, though, my concern is that, once we unleash this wave of agents, maybe they're not acting benevolently, and we need to be in a place where, that's okay if they don't act benevolently. We have the proper controls in place.
You also think about hacking, right? And data breaches and stuff like that. If people get access to, it's normally a low-level employee or someone, not even knowing, and then they have access to all of that by default. Yeah, I mean, what you said there, building agentic AI with that in mind or with those guardrails, it's, when you build a software system without thinking about security and then trying to do it after the fact, it's always much more difficult. And there's so many things like issues that go with that. And it just extends timelines and all of that stuff. So doing it upfront is probably the smartest and best choice.
Right.
Especially
yeah. Retrofitting the system, patching the system, that never really works well.
Never. But yeah, I mean, I'm very excited about agents as well. I've got a recording later on today with a founder of a company that's doing amazing stuff with agents. Yeah. I'm not sure the timing of when these two will come out. So if they're not side by side, don't worry about that. And then for me, the intersection of hardware and software. So like agents, AI, AGI with robotics, or even, we're probably a little bit far away from having a humanoid robot that you can communicate with in your home. But now with your Siri or Alexa and stuff like that, getting a lot more, a lot smarter, or systems like that, where you're incorporating it, and they might know what your day-to-day looks like, your calendar looks like, the weather looks like, your commute looks like, and all of that stuff, and help you plan your life more proactively. And things like that kind of excite me. Freak some people out because they like, oh, I've seen her and I know where that goes. But, yeah, those kind of things I'm very excited to see. Robots in our day-to-day life, AI in our day-to-day life, and how it's going to impact us instead of just helping to write an email and stuff like that.
Yeah. I think that'll be so exciting. But I'm actually of the group that finds it a little bit scary, because of all the things that I mentioned before. The robot does things that it's not supposed to, and then what do you do then? Right? You're fighting against a metal machine.
Yeah, that's a very good point. Yeah. You don't want to be doing that, or it like falls on your pet or something like that, or your child. You don't.
Yeah, exactly.
Yeah. All right. Look, well, we're almost at time. I really appreciate you sharing all of your insights and the journey here. Before we wrap, is there any advice that you'd give to those that are looking to start their own venture and go down the same route, or similar route that you've gone down?
Yeah, I think the first thing that I would say is that things will never never sail smoothly. Oh, man, that was a terrible. Let me repeat that. Things will never sail smoothly, and as a result of that, I think you need to go in expecting that sometimes will be tough, and you need to find the right group of people around you where instead of getting upset at one another, instead of being frustrated with another, instead you'll be able to kind of pick one another up, provide mutual encouragement, and remember that you have this kind of shared vision, and you have this shared excitement over something that you all believe will have a tremendous impact one day. And just focus on kind of building that without um, getting kind of into the wrong headspace. I think another part of that, right, is, in my opinion, having grit is so critical in the startup space. Just being able to kind of persevere, to kind of push through when things are not going well, being able to kind of pick yourself up, and keep kind of chugging along in pursuit of that kind of North Star, that vision that you and your team have.
Amazing. Amazing. And where can people find you and Opaque and follow along with your journeys?
Yeah, so Opaque, our website is opaque.co. We have that nice .co startup domain. And then we're pretty active on LinkedIn as well. So if you just look us up, Opaque Systems, you'll be able to find us.
Perfect. We'll link all of that in the show notes anyway. But look, Chester, thanks again. I really appreciate it. I learned a lot. I'm sure our listeners will as well. And hopefully we'll get you back on the show maybe next year, see how you guys are progressing and all the cool stuff you've been building.
Yeah, absolutely. Thanks so much, Greg. Thanks for sharing your insights as well, especially about the robots. Super interesting to hear that.
My pleasure. Take care.